Students, see experiment 5 using a meter bridge to verify the law of combination of resistances when they are connected in parallel. So, parallel combination. Okay. Now, apparatus required. You see, we are having meter bridge. Okay. 100 centimeter long wire. It is mounted on the wooden board. Here we are having meter scale, resistance box, 2 wires. Here you see 2 wires of known resistances. Okay. First wire of known resistance, second wire of known resistance. Okay. Now plug key, eliminator which is connected with power supply. Now you see galvanometer, one end is connected with this arm, it is for S. Here we have connected 2 resistances in parallel and another end. Here you see we are having one resistance box. Here we are having resistance box and 2 wires, one wire, second wire. Now I am joining. Okay, just a minute. Now see arrangement. Okay, apparatus, here we are having our arrangement. Now come to theory. We know that when 2 resistances are connected in parallel, equivalent resistance Rp, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. After simplification, we get 1 upon Rp is equal to R1 plus R2 divided by R1 into R2, or Rp is equal to R1 R2 upon R1 plus R2. It is equivalent resistance when 2 resistances are connected in parallel. Now see circuit diagram. Meter bridge wire AB, resistance box. Here in this arm, it is S arm. We have connected 2 resistances R1, R2 in parallel. Between these 2, one terminal is here which is connected with one end of galvanometer. Another end of galvanometer is connected with jockey. And we know that balanced condition for Wheatstone bridge, it is P upon Q is equal to R upon S. Suppose S, here we are going to calculate resistance of this arm, so S is equal to R Q upon P. Now if you see the circuit diagram, here L, when we put jockey on the AB wire, okay, jockey AJ will give length L in centimeter, AJ is for P. Now JB will be 100 minus L, it will be in centimeter. Okay, now this JB is for Q. R, we are taking resistance from R. Different values of resistances we will take out from resistance box. After, here you see our observation table. After substituting the values, we can calculate S. Okay, after taking a number of observations, okay, we will calculate average S. Now here, keep it in your mind. If you are having known value R1 and R2, you are knowing the resistances of R1 and R2, you know very well equivalent resistance when they are connected in parallel. Okay, so that After getting a number of observations, okay, you can check, you can calculate error, okay. Now come to this experiment. Meter bridge. One end of meter bridge is connected with resistance box. Now another end of resistance box is connected with two different wires, okay. They are connected in parallel. I am joining wires, okay. They are connected in parallel. Now between this arm resistance box and these two arm wires, they are connected in parallel. We connect galvanometer. Another end of galvanometer is connected with jockey. Now see power supply, eliminator. Eliminator is connected with AC circuit, okay. It is eliminator so that we can get DC. Now this eliminator is connected with plug key. Now here, when after joining our circuit, then we put key here and check our circuit, okay. Now I am taking out one resistance from resistance box and see, when I put jockey at one end, galvanometer is showing deflection in one side, okay. Now I am putting jockey on next extreme end. You see galvanometer is showing another deflection in another side, okay. Now for balance condition, this pointer should be at 0, so we get null point, okay. Now see, it is null point. When we put our jockey, it is, see, jockey is moving and it will come to 0, null point. And when it comes to its null point, we measure L. L will be in centimeter, then 100 minus L. Suppose here we are getting 40 centimeter. Here for Q we'll get 100 minus 40, that will be 60. Okay, and after a number of observations, we can calculate S, we can get average value of S, okay. Then we can compare with theoretical value of resistance, when equivalent resistance, when different resistances are connected in parallel. Now here, keep it in your mind. If you put 1 ohm, if you take out 1 ohm from your resistance box, sometimes you will get one-sided deflection. So start from, we generally start from 2 ohm, okay. Then you get 2 sides deflection and you will get null point nicely. Second thing, avoid this type of connections. Try to consider single connecting wire, okay. If you join small pieces, you will get potential drop, because you see your eliminator is supplying 3 volt and sometimes 2 volt, 2.5 volts, and if you get more and more potential drop, you will be in trouble. So be careful for it. Now it is very simple experiment, and before leaving we should take out key, okay.